Time for a lesson. What do you mean time for a lesson? I'm busy driving an excavator here. Can't you see? The excavator is part of the lesson. It's we're going to be making hydraulic syringe excavators, so we may as well take a look at the mechanisms that allow an excavator to work. Like, oh, don't go down. There we go. Go back up. Back up. Oh, this excavator really doesn't like it when I stretch it out all like that. There we go. Come on back up, my friend. There we go. The angles are just not good when you come down like that. So let's take a look at some of the mechanisms that an excavator uses. And there's our first arm right there. And we can bring that up or we can bring that down. There's our second one, and you can see the hydraulic syringe actuating right in there. In this case, not so much a syringe, but a hydraulic actuator. And then you can bring the arm around like that. Now take a look at that bucket and what that bucket's doing right there. And that's not just a direct syringe connection, but there's a nice little mechanical movement in there that is allowing us to translate that linear motion into a rotational motion for that bucket and getting a good scoop out of it. You'll also notice some interesting things about the geometry on here for extending and retracting this arm. That they haven't got everything just all in one straight line because they need that to be able to have torques and moments while still allowing room for the hydraulics to move. Got one tucked away right down in there, and we can move that back and forth. So anyways, a cool little excavator program that lets you go around and dig up rocks in a virtual world. Where's my arm? Bring that arm down. There we go. And it's pretty cool to be able to go out there and wreak some havoc on this virtual world. The Excavator Simulator is a free download for Mac or for PC, and it is available at www.fabrejean.net. Fabrejean. And it's actually just a little programming practice that this fellow made up to show off his programming skills. But for our purposes, go ahead, give it a download for Windows or for Mac, and you can try it with your gamepad or just with your keyboard. But most importantly, you can get a sense for the mechanisms in this excavator's arm, because we're going to be creating something quite a bit like it. As with all of our CAD problems, I like to start out by doing a little bit of a sketch of what it is that we're going to be designing. And it gives me a chance to just think about where some of the key parameters are going to be and how many holes we're going to need and just how things are going to come together. And so I've sat down and made a little bit of a sketch. And for this problem, I also took a little bit of time and did some research. And I went online and I just looked up excavator geometry, kinematics, dynamics, or all other good words, excavator design. And you'll find that Joe Frankel here at the Georgia Institute of Technology published a lovely paper describing all the forces and mechanisms that are happening on here and mathematically derived the motions and the optimal lengths. And for anybody who's studied engineering and done their vector math and trigonometry, it's just a beautiful piece of work that he's done explaining everything that he needs to come up with his simulation of the excavator arm. And of course, there's people who've looked just at the bucket link. And so, this research comes out of India on this paper, and, they give you a nice little diagram of how it's able to reach down. and the forces acting on it. And they do finite element analysis of the bucket link in here to take a look at where it's under load and where it's not. And yeah, that's all completely irrelevant to what we're at a bit higher level. But it's good to know that the problems that we're dealing with for our little syringe-powered excavator at a bigger level are being played out everywhere. Now, because this is going to involve a mechanism, I also wanted to go through and take a look at a few different ways that we could use Fusion 360 to optimize our design without having to go through all the math that Joe did at the Georgia Institute of Technology. And one of the ways that we could do that is by coming up with a parametric linkage. And we've used some aspects of this in our design already. In our previous lesson, you were able to link a few objects together and have their motions constrained by the other objects going around in there, but we didn't really make it fully parametric. Now we know that we've made some things parametric in Fusion 360 by being able to go back and change the dimensions. But what we want to be able to do for this structure is we want to be able to take a look at all the dimensions and sort of change them on the fly as we're moving things around to see how that comes out. So for instance, right now you can see that in this 4-bar linkage, as I rotate this back and forth, this arm really swings up and around right there, and that's because the upper arm is shorter than the lower arm. But we can come in here, and the way I've set this up, I can come down here at modify and I can change parameters. And the critical dimensions of this linkage I've set up completely parametrically in what's essentially a little spreadsheet. And I can come in here and I can change one of these links. And let me take the top linkage right here. I've got it set to 100 millimeters right now. I don't have to go back to the sketch. I can just type in 140 and that extends. And for my vertical ones, I don't have to go back and edit their sketches. I've got them both linked into the same parameter. So I can take that up to 80. Bang, they get larger. I want to go a bit bigger. I take them up to 100. And now I've got to exit out of the parameters. And now I can come in here and I've got a completely different mechanism because it doesn't really want to go up and around because the geometry on that structure has changed. So if you need to model a mechanism, you can come in here and using your parameters, you can try different lengths for your arms, and you can come back in here and let's change our parameters again. Let's set the top and the bottom arms absolutely equal, shorten up the vertical arms a little bit. And what you can see now is classic 4-bar mechanism right in here, where because these two are the same length and these two are the same length, as I move this up and down, this arm right here remains parallel to this arm right here at all times, but moves through a range of motion. And if you get into doing VEX robotics of any kind, you will find that high school students have the most amazing collection of 4-bar linkages, and they'll be throwing around terms like the double reverse 4-bar and the 6-bar, and they're all very interesting, very cool mechanical linkages. And they build them and model them using pieces of steel and aluminum, but you can also visualize them right inside the computer and with a change in a couple parameters, see how they work. So what we want to do is we want to build a fully parametric bucket end for our excavator so that we can play with some of the values to make sure that the syringes that we have, which are not parametric because they're fixed by the physical reality of that syringe, that we can match our syringe up to some dimensions on our excavator that are going to work for us to excavate as much as possible. So what we want to record today is a simulation something like this, where the gray rectangle down here at the bottom that's moving back and forth represents our bucket, and we want to be able to see that that bucket can extend as the syringe extends, comes around in here, and scoops up our dirt, our plastic beads, and then when we retract the syringe, comes out this way and it dumps it. And we want to be able to make the best use that we can of the entire stroke of this hydraulic cylinder that we have right here, the syringe right here. And in this case, we're using a 10 milliliter syringe, which has a stroke of about 72 millimeters. So we need to play around with some of the dimensions right in here. And there's critical dimensions based on how long each one of these arms is, the distance from this pivot point to each of the other pivot points, and certainly the location of the syringe right out here. Now I've included two other points that we can play with later on, and this of course is where we're going to connect to the next arm right in here, and so we can start building up the entire arm. But for right now, this is one of our more complex links, and we want to start by building this up as a part right here, just where we can visualize it and get some measurements. Now, right now, we're only looking at it in the two-dimensional perspective. If you flip it around to the three-dimensional perspective, you can see that obviously we're going to have to fill in this entire arm right here with a solid piece of material. Right now, we're just concerned about where those holes are going. And then we're going to have to mirror that over. We can play with the lengths right in here, mirror that over right here so that we can have another piece right in here, and then we start building up our syringe excavator from that point. But for today, we want to take a look at the parameters and how we can change them. And let me just go back to our two-dimensional viewpoint on here and the impact that some of those can have, because we're going to be able to come in here and we're going to be able to change some of these parameters. And I've got a whole list of parameters here that we can change. But for instance, if you change this arm right here, and I'm calling this the linkage, this is the linkage, these two parts right here, and this one is attached to the arm, this one's attached to the bucket. So I have linkage arm length, referring to the length of that arm. And if I bump that up to 50 millimeters, you can see that that changes the shape of everything, and it's going to behave differently, and I'm going to have a different number of degrees that that passes through. And I've got it working okay at where I'm at, but you're going to be able to come up with your own design. And then this is also going to let you then design your own shape for the bucket so that you can have the most efficient bucket for scooping up the stuff that we're looking for. So I'll give you a little guide through on how I went about creating all this. I hope I remember what I did, because it's actually working pretty well. Now, the first thing I'm going to assume is that you've got a 10 milliliter syringe designed and linked and ready to go. We've covered how to create your syringes in previous tutorials. So if you don't have your 10 milliliter syringe hooked up and ready to go with the clamp or the collar on the bottom and the cap up here on the top so that you can drag that up and down, go back and take a look at some of our previous tutorials where we've put our syringes together and where we've modeled our syringe. You're going to have the plunger, you're going to have the syringe body, and you're going to have to apply some joints to get those all together and make sure that's working nice and smooth, because we are going to need that assembled and ready to go at a later point in this process. So if you've got your 10 milliliter syringe working and ready to go, then it's time to start a new drawing. And like I like to do with all the drawings, as soon as I start it, I like to come in here and save it. And make sure you save it into the same project, the same list of files that you can see over here that has your syringe ready to go in there. And I'm just going to call this the arm and linkage. And I'm going to call it arm and linkage 2 because I've already made arm and linkage 1. And that was the one that I was showing you just a couple minutes ago. This is my, go back and see if I can do it the second time around. Okay, so that's saved right in here, and I'll just let it finish saving. And here we go. Now, keep in mind that what we're going to be doing is we're going to be creating components underneath here. So just as with some of the previous things that we've done, we need to have these separate components so we can joint them together, and where they sit in the hierarchy really matters. So what I'm going to do is I'm going to start by creating a new component. That was a right click right here at the top of the project. and I go new component, and the new component pops up in here. And I'm just going to call that new component the arm. What did I call it in there? Yeah, I'm just going to call it the arm. Okay, now this will be the end arm, but we can come up with other names. This is the forearm, yeah, sort of from the elbow to the wrist of our project right in here. And so now that this dot is turned on and we've got this component activated, all of our editing is going to take place on this component. Later on, we're going to come back and we're going to create some new components, and then we'll be able to work within those components, and then we'll be able to link the separate components together. So it's kind of like having separate parts, and then we put joints onto them. Okay, so what we're going to do in here is, as with everything, we're going to create a sketch and choose a plane. Doesn't matter which plane, we're going to keep working on the same plane. And what we're going to do for this one is we're going to create some construction lines. And so turn on your construction line tool and come out and pick a line right here. And you might have to zoom out a little bit because we'd like to create a line that's going to be somewhere around 240. Doesn't really matter how long, millimeters long, and we'll finish off right in there. Okay, now what we're going to do is we are going to create another line that comes vertically up from here, and each of these lines are so that we've got a reference point, we're good on that, for each of our holes on the arm. And if you'll recall back, I've made a sketch of this, so I know that we're going to need 5 holes into our arm, so I'm going to have 5 points on here. And in my reference sketch, we had them come up somewhere along here. Now I'm being very careful to make sure that I don't end up getting something like that. See that little blue line come out? And that says that's going to be at the exact same height. That's going to impose a constraint on it. The only constraints that I want to happen in here are these perpendicular constraints. We're going to come back and dimension them in more detail later on, which is just fine. But yeah, do another line here, and down at this end, I'm going to need 3 of them. One kind of up here. If you want to do this a little bit quicker, you can right click and go repeat line. One will be kind of down here. And then out at the very end right here, let's repeat line, and we can tie that in right out here. These last 2 we're not going to worry too much about today because they are going to be used for mounting this to the syringe and the pivot point for the joint to the next section of arm. Down here is where we're going to be hooking up our linkage and our bucket, and that's going to rotate up and around over here. So now to make this parametric, we want to add some dimensions in right here. So let's start by creating some sketch dimensions, and for right now, I'm just going to go and a dimension from here to here. And I'm just going to leave it at what it's at. We'll come back and we'll edit these later. From here to here. From here. And there's no particular reason that I started my measuring at this end. Somebody could say it's more logical to start at that end and use that as your baseline for your measurements. I just started at this end, and now we'll measure dimension each of these heights right here. So what we've got now is basically we've got a little piece of graph paper here with X and Y measurements indicating the location of where we're going to put holes. And so what we're going to do is we're going to create a little hole. Oops. So these holes are actually going to be real. Let's undo that. We need to turn off our construction line to make some real genuine holes that we can work with. And these are going to be the screw holes right here. So just at the center, each one of these. And again, like I say, don't let any of those little blue lines pop up on you, because if that happens, you may have a constraint that you're going to have to go back and undo. Just keep an eye as you do that. The constraints, if there's any, should pop up and you should see them coming along in there. Okay, so now we've got X dimensions and Y dimensions for where all of those holes are going to be relative to some arbitrary baseline. And so let's come along here, and now those are going to be holes, so we need a circle that goes around them. And here we do want some constraints because those will be concentric constraints, so you can see the little concentric symbol pop up after I make. Which one of those did that not show up as concentric? Let's just make sure that is concentric. If you didn't see the concentric symbol pop up on any of these, hook that up and it says, okay, it's over constrained. That constraint is in there somewhere. And let's finish this off by creating a hole. Oh, I don't want to repeat concentric. I want a center diameter circle. Just a little lag there from the computer. And there we go. All right, so now we've got all those holes on there. It's time to start adding some parameters to make this parametric. So we're going to come in here and we're going to modify and we're going to change some parameters. And right now we have no parameters. So I'm going to create a parameter in here. And so I hit the plus button right next to user parameters. And I'm going to call that hole ID. Okay, for inside diameter, and we are going to set that to 4 millimeters, and this is 4 millimeters is inside, yes, inside diameter for a number 6 screw clearance hole. And there we go. We're being good bilingual Canadians. We're measuring and drilling in millimeters for an imperial arbitrarily sized screw. So apologies to anybody else in the rest of the world that actually uses metric screws. You could put a 3 millimeter diameter screw in there or a 3.6 millimeter diameter screw and just create that size. But over here we've got this lovely nation to the south of us that still really likes to have their own style of measurement. Okay, so we're going to have the whole inside diameter right there. And well, let's just go ahead and apply that to all of our dimensions in here. So I'm going to come along and with the dimension tool, click on that circle and just click where you want it to go and type H into your keyboard. And you'll see whole inside diameter pops up right there. And now that changes to 4 millimeters. So that's where our number 6 screw is going to be able to go through there. And we're going to be able to go through and dimension all this. And seeing as how we're going to use the same screws everywhere, I don't have to keep retyping that. I can just come back and type that in, or I can type in whole inside diameter. It really doesn't matter. Now, which you do, it's probably just as quick, and it all refers back to the same thing. Just make sure that whatever you get, that they're all coming out at the right size for a number 6 screw. Okay, everybody says 4 right in there. And for right here now, we're just going to use these little circles right now as markers for where the hole is going to go. You can see that later on, we're going to be able to come back here and we're going to be able to build an arm around here once we get all the known dimensions and we can put nice smooth radius curves on there. I'm not even going to worry about the look of the arm until we know something about the geometry of the arm. And the geometry of the arm is going to be determined by where all these little holes go. So it's kind of like when we make our trusses. We don't actually worry about what the rest of the truss looks like. We just worry about where the nodes are. And we're looking at nodes right here. Now, just to keep things a little bit neat, let's come in here and dimension this one. And we'll just take whatever that dimension is and we'll add 4 millimeters around it. Okay, and that way we've got these little brackets that are just going to sit there and represent our holes. And I'm just coming over here, and instead of retyping in, oops, I clicked on the wrong one right there. Let's undo that. That one should be right there. And this one, oh, I lost my dimension tool. That's what I want. That one should come in right there. That one should come in right there. And now we've got all those holes. And we didn't need to do that. They just look nicer that way. Okay, so we've got those little spots positioned all over the place. Now we're going to take care of their X and Y coordinates. So we've got the dimensions in here already. What I'm going to do is I'm going to call X in this direction, Y up and down. So I'm going to have X1 to hole number 1, X2 to hole number 2, X3, and X4 as those dimensions. So I'm going to create some parameters. And let's see, project includes, not create, it's modify. Modify, change parameters, and to create them, I hit plus, and it says, what do I want to call that? I'm going to call it X1. Actually, maybe I'll use a small x, doesn't really matter. And I know from my previous experiments, I'm going to save you a bit of hacking around, that 20 millimeters works pretty nice for X1. Okay, and we can comment this. So if we come back and look at it a week or two from now and we forget what this is horizontal distance from end hole to first hole. Okay, and then I'm going to come in here and I'm going to create X2. And X2 comes out at about 150 millimeters from my design that worked. And then we're going to come in here and this will be X3. I had that set up to about 210, but that's probably longer than it needs to be. We can change that later on. And X4, which is going to be 230. Okay, so now we've got all those dimensions in there, all parameterized, so we can come in here, type this in and say we want X1. Okay, and you can see that has now become fx. That means it's a function. It's looking something up somewhere. It's not just using a hard number. This will be X2. Okay, that changed that dimension a little bit. And that's a good thing if you can see the dimensions changing around and they're behaving the way that you want them to. X3. Type X, click on X3, press enter, and double click on that. X, X4, and press enter. Now, depending on how long your shape was, it was maybe a better idea to set this one first, or you might have to play around them in different sequences depending on how you've got them set up. But what's nice now that we've parameterized all that is that later on when we're trying to piece this arm together, we don't have to come back in and edit this sketch. We just go modify parameters, and all of our parameters are sitting in one spot for us waiting to change them. Let's add the Y dimensions as parameters right now. So change parameters, add, and I'm going to start with Y0 because there is a 0th hole because we have to have that height of that first one. And that one seems to come in, I think I used 20 millimeters. And we'll just say height of first hole from baseline. Okay, and then I'll come along and I'll go Y1. And Y1 actually came in fairly nice, also at 20 millimeters. And then we'll put Y2 at 40. Okay, and Y3 at 15. And right now, some of these are just kind of arbitrary. We will tune them up as we come along. You'll see in a minute. Y4 and that seems to work out around 50. Okay, so we've got all of those in there. And so this will be y0. This one right in here will be y1. This one in here will be y2. This one in here, y3. This one in here should be y4. Which means that you can now sit around and say, I spent the afternoon looking at this CAD program going, why? All right, sorry, done with the dad jokes for now. We now have our sketch fully dimensioned. Now, like I say, we are going to come back later on and we're going to use some of these dimensions. We're going to create bigger circle around there to have a nice radiused corner, and we are going to create a solid piece of what would probably eventually become MDF cut on the laser cutter or hardboard cut on the laser cutter. You could make it out of sheet metal, and you could print these dimensions out, and you could print your profile out, cut it out with shears, hole punch your holes. You can make it nicely out of sheet metal. Whatever technique that you want to use to make it, you can do. Heck, you could 3D print it if your 3D printer was big enough. Let's finish that sketch right now. And now let's make these parts real by bringing them into the three-dimensional world by doing an extrude. And we're going to pick each of the outside diameters. Remember to leave that little hole in the middle for our joints to format. And did I get them all? There we go. 5 of them have been selected. And we are going to extrude them out 3 millimeters, which is approximately thickness of the MDF that we're working at. And so right now, this is just a representation of the profile of that arm so that we can work out the geometry of that arm. Okay, so we've got our first part in here, our first component ready to go. Now, what we need to do is we need to come in here and create our linkages. So I'm going to come in here and I'm going to going to activate the project as a whole, and I'm going to right click, new component, and you'll notice that the new component right here is at the same level of the hierarchy as this one is right here. If I'd had arm1 selected when I created the component, that would have made this a child object of arm1. It would have been underneath there and subject to arm1 for control. Now this is an independent project because it is, or an independent component because it's up here at the same part as the rest of the project. And so what I'm going to do is I'm going to call this linkage arm. So this is a linkage on the arm side. We'll also have a component that is the linkage on the bucket side. And again, we're going to come in here and we're going to create a sketch, and we'll just choose the plane that we're working on right here. And again, this one only needs 2 holes. And that's okay if those 2 are lined up because they're going to be on the same line. So it's going to have 2 holes, and it's going to have 2 circles that go around the outside right there. And now what I'm going to do is I'm just going to pick up a line, and I'm going to get that little X mark on there so that it's touching that line. Come over there. Oh, and you can see if I zoom in right there, you see I've got the little tangent sign showing up. That's perfectly fine. That gives me the tangent constraint, means I don't have to come back and put a tangent constraint on it later on. And there we go. So we've got 2 tangent constraints on there. We've got 2 concentric constraints, so those circles stay together with each other, but you can see we don't have tangent right over here. So pick up tangent and say U should be tangent to right there. And you can see now we have a tangent constraint pop up in there. And U should be tangent to right there. And that pops up right in there. Now, it's possible that if you drew that line perfectly horizontal, that there is a horizontal constraint that kind of looks like that sitting right in the middle. And if you've got that, you're just going to need to hit escape, come in here, find that constraint, highlight that constraint, and delete it. Okay, so right now we're pretty good right on here. Now we're just going to bring in some dimensions right here, and we're going to say, well, this one right here is going to be hole inside diameter. And this one right here is going to be hole inside diameter. Now, the reason I'm using hole ID as a parameter instead of just using 4 everywhere is maybe as we assemble this, we find it's a bit floppy and we want to go and change from a number 6 screw to a number 8 screw or something like that. And if we do, then we just come and change that one parameter and everything in our drawing immediately changes. All right, and then we're going to need an outside dimension for this hole. And let's just make this equal to our inside hole. We'll say plus 8. Let's make it a little bit bigger. Because this one's actually going to have a little bit of rigidity to it. And we'll set that one equal to that same dimension right there. Okay, now what we need to do, our key dimension on here is going to be the distance between right here and right here. So pick that center point. Oh, just a minute. Thinks I'm still dimensioning a circle. Hit circle, dimension again. Pick that center point. Pick that center point, and it's not giving me what I want. Dimension. I pick that circle. I pick that circle. There we go. And for right now, I'm just going to leave that sitting at 60 because now we need a parameter for this one as well. So we're going to come in here and we're going to modify, change parameters, and we're going to create a new parameter that functions for this drawing. And we're going to call this linkage arm length. And the linkage arm length that worked for me was 50, and this is hole to hole length of the linkage attached to the arm. Okay, again, comments are your friends when you come back to look at this later on. And that's in there at 50 millimeters, so I click OK. I click on right here, and I go L for linkage arm length. And now that becomes 50 millimeters right there. I can finish my sketch, and I'll rotate this just a little bit so you can see the extrude as it happens. And extrude, bang, bang, bang. We want those 3 surfaces right there, and we'll extrude at 3 millimeters. Now I should probably be doing that as a parameter too. We can parameterize a lot of things when we do this, but I'm just working on the assumption that we'll use laser cut MDF, 1/8 inch MDF, 3 millimeters. Okay, so that part is all created in there and ready to go. And you'll notice that because I'm working on this and the linkage arm is the activated component, that everything else is grayed out. Okay, so if you see that happening and you want to activate everything like we will later on when we come back to joint things, you come back here, click on the little dot right up here, that activates the entire project. You can also hide things completely. You can see the eyeball right in there. You can turn things off, and you can make them completely invisible as you're working on things too. You can turn the entire project off, but we're not going to worry about that right now. So we've come back up to the top, and we're now going to create the next part of our linkage. And so we'll come in here and we'll go new component, and this is going to be the linkage to the bucket. So linkage bucket. I guess you could call it the bucket linkage and the arm linkage. Just I've gotten into this habit that if I have 2 things that are associated and I put the same letter at the beginning, then when I sort them for some reason, you'll be able to see them immediately associated with each other. It doesn't really apply in Fusion 360. It's just a hangover from some of the other programming that I've done. And believe it or not, yes, this is programming. We're actually programming a shape into here and establishing rules, and that's why we're able to get a simulation out of it. So let's come in here, and we're going to build a linkage just like we built that one. So I'm just going to do it quickly, and if you run into any questions, you'll be able to come back and figure it out from what we did in the past. But again, I'm not worried about where it goes. Not worried about where it goes. Let's go in here and lines. Our tangent constraints. I really like making things tangent, as you can tell. Okay, we're going to come in here and we're going to create some dimensions. Hole inside diameter. Takes that down to 4. Hole ID takes that down to 4. And set this one to be equal to D40 plus 8. And this one to D41 plus 8. Okay, there we go. And then our critical dimension from the center of this hole to the center of that hole. And that we are going to turn into a parameter. I'm just going to leave that there for right now. I'm going to come up here and change a parameter and create a new parameter. We had linkage arm length. We're going to have linkage bucket length. And no, it doesn't let you put spaces in there in case you were wondering. And linkage bucket length for me also seemed to work out nicely at 50. Okay, and there we go. Come in there and linkage bucket length. And you can see now we've got fx for all of our dimensions in here, which is good. That means they're all parameterized. I'm going to finish that sketch. I'm going to come in here, go and extrude, pick my 3 objects, and extrude it 3 millimeters. Okay, so now we've got our main arm body, we've got the 2 linkages. Now we just need to create a bucket. And so again, we come up to the top, we activate the entire project so that we tell it the new component comes right underneath here. Nice straight line coming down the side. We don't need anything being controlled by a more senior thing in the hierarchy, and we're just going to call this the bucket. Now later on you can come in and you can design your own bucket, and you're going to be able to pull this component out and put in a nicer bucket. But for right now, what we're going to do is we're just going to create a sketch, keep everything nice and flat on the same plane. We're going to create a 2-point rectangle about the size of the bucket that we're going to create, and then we'll come in here and inside that bucket we'll put a couple of holes. And again, I'm careful that I don't end up getting any unwanted constraints in there as I go ahead and create that. Watch for those little lines as they pop up. You can always delete the constraint later on, but right now I don't want any additional constraints. There's one of those horizontal and vertical constraints. That's perfectly fine for the bucket because that gives us some dimensions within its frame of reference. Okay, add some dimensions right here, and I want to dimension your radius. There we go. And sorry, your diameter, hole inside diameter. Hole inside diameter. And just as we did before, I'm going to give it some X and Y dimensions right here from the edge. So from that circle to right there, I am going to create a parameter for that. And from that dimension to right there, I'm going to create a parameter for that. And right in here, and right in here. Then I'm also just going to parameterize the size of the bucket because we might need to change that a little bit later on. And I'm also getting strangely obsessive about parameters. Okay, let's come in and create those parameters because that makes me happy to do. I really like parameters. So let's come in here and I'm going to call this the bucket outer X for the outer side of the bucket, the dimension, horizontal dimension to the hole. Bucket outer X. And I think on mine that worked out well at about 14 millimeters. That's the dimension from outer, I guess horizontal dimension from outer edge of bucket to outer hole. Okay, so then we'll create bucket outer Y, and on mine that worked out to somewhere around 8 millimeters. And then we'll create bucket inner X, which was 8 as well, and bucket inner Y, which was 8 as well. Oh, sorry, goes right there. I was trying to make that in the comments column. And then finally, we'll just have the bucket horizontal. Actually, we don't need to parameterize the outsides of the bucket. We can always come back and change that. We're going to create our own bucket later on anyway, once we know all the dimensions. And it's the dimensions that are critical for figuring out how it moves. So this is going to be bucket. It's on the outer side. And this is a horizontal dimension, so we'll use bucket outer X. And here we're going to have bucket outer Y dimension, the vertical drop down below. Here we're going to have bucket. This is on the inner side, and it's horizontal. And here we're going to have bucket inner side Y dimension. So now we've got that all set up, and these dimensions here, just to keep that from getting moved around too much, let's just make this a little bit wider so we've got a slightly bigger bucket. Maybe not 50. Let's take that up to 45. That gives us a bucket closer to what I had in my drawing. I think I'm going to finish that sketch. And again, this won't be the final shape of our bucket. This is just to get to a body study so we can take a look at the geometry and see how things move. And we'll extrude this 3 millimeters. Okay, so now we've got all of our parts in here, and it's time to start putting them together. So let's come up and activate the entire project. And we've done some work with our linkages. Now, as you'll know, the first thing we need to do when we want to test something and see if it's going to spin is we need at least one object to be grounded. And for right now, we're going to assume that the arm right here is our most important part, and we are going to ground that. You can see that little pin appears right in there. So when we start jointing things to it, that arm's not going to start flopping around everywhere. Okay, now what we're going to do is we're going to come in and we're going to create a joint. And what we're going to do is take the inside edge. Doesn't have to be the inside edge. I'm just being fussy here and playing with a 3D mouse. Come in here and make sure you get right on the center of there so it knows that you've got a circle. And this is going to come down, and this is going to meet right up with right there. Now, mine, the last joint I created was cylindrical. Your last joint was probably rigid. We need to come in here and we need to control the motion. And I'm going to say that I want that to be a revolute joint, so it's not popping in and out. It's just spinning around like that. And I'm going to say OK. And then I'm going to pick on that and rotate it up out of the way so I can see this, because I'm going to have to also put part of the bucket right in there. Okay, so now I'm going to create another joint. And some components have been moved. This is just fine. That was what I did right there. Capture the position so it doesn't go setting that all back. And then I'm going to pick the inside right here. And I'm going to connect it to the outside right there. And now there's a revolute joint that's spinning around. and that looks like it's working A-OK. So I'll click on OK right there. And now I'm going to put this linkage right here. Create a joint off of right there. That watch where your little crosshairs go. You want to make sure that you've got the dot right on the surface. And that's going to come up right around here. And the dot's right on the surface right there. So now that's pivoting around right in there. That's all looking pretty good. So I'll click on OK. And my final joint right down in here is going to be a joint between this outer surface right here and this inner surface right there. Don't worry that it jumped away from what it was already joined to. It's going to come back in there. Now, the one thing I am going to do is rather than just have it be a revolute joint, which doesn't allow any movement in this direction, I'm actually going to change that. Come over to my motion right here. The computer seems to be lagging for a minute here. I want to come to my motion. Thank you, computer. And I'm going to change that to a cylindrical joint. And the reason I'm changing that is just because we don't want to start putting too many, we don't want to start removing too many degrees of freedom. And if when you manufacture it, there's a little bit of slop in there and your design doesn't allow for this side to be just a little loose in that direction, then you're going to run into a problem. So now I'm just going to say OK right there, and that's looking a bit garbled. So we can come in here and we can rotate that around. What's going on? Oh, we ended up getting too far rotated around. Something's in the wrong position over here. Let's drag this up. And it's like something got flipped out of place right there. I mean, the linkage is working beautifully for me, and it certainly didn't do this to me the first time I designed it, but it's good that we saw it because it may end up doing this to you as well. Let's see if we can fix that up a little bit, because what we need to do is we need to rotate that around back into that position. Let's just try and undo right here, undo a couple of our moves, and watch our joints right in here. That cylindrical 4 right in there. I'm just going to come in here. Now our joints are appearing on our timeline. So if we want to come back and edit that, we can just double click on that point on the timeline down at the bottom. And let's see. So why did that pop in right there? So when that came up there, I wanted to link that together. Let's just cancel that for right now. I'm just going to delete this joint right here. So you can come in here on your timeline, right click on it and go delete. And let's just reposition a few things so that this is more likely to be in the position we want it to be when it goes to join. There we go. We will give it a little bit of assistance in figuring out the easiest way for it to go together right over here. So the timeline's your friend. You can always go back and say, oops, you're not doing what I want. Let's fix it up. Then you can put the joint that you want in, capture the new position, pick that space right there, pick that space right there. That's spinning around. It still knows to make it cylindrical, and click on OK. And now if I look at that from the front, or whatever, for just whatever you're working in, we should be able to come in here and rotate that and see arm movement right in there. That is working out pretty good. Now, you will notice that if you look at it from a 3D perspective, that this bucket right now is pushing into this space right here. So when it comes time to doing a full 3D design, we may need to cut away a bit of material right in here so that we don't end up getting interference between our parts. But that's easy enough to do. You can radius a corner, tighten that in a little bit, play with some of your dimensions. You can have the bucket drop down a bit here so that it comes up past right there. And of course, then we'll have our arm on the inside, so you'll also have to figure out how to build that bucket to work with the rest of your arm. And that might involve spacing your linkages out a little bit differently. But that's the beautiful thing about getting it all worked out inside the computer. Okay, Now, we've accomplished a lot right here. We've got the basic mechanisms of the linkage working right here. And what we want to do right now is we want to quickly give that a save. So if you've got everything working, always remember to save regularly, because computers have this horrible way of making you sad when you don't save regularly. Now, you'll recall earlier we said that we're going to need to have our 10 milliliter syringe. We're using the lightest, smallest syringe because this is the most extended part of our arm, and you want to have your lightest components out at the most extended part because there's a lot of leverage on any extra mass that you have out there. So we're going to drag that right into our project right here. And there'll be a bit of whirring around as that comes in. And you'll see that this has come in at the same level of hierarchy as everything else in there. And we're good to go with that. We're A-OK. And so now what we're going to do is we're going to hook this in, and this part right here is going to mount to right here. This part right here is going to mount out to right here. And so let's create a joint. We'll capture that position. We'll come in right here and see if you can get that entire cylinder right there in the little dot. That's going to spin around and come in right here. And it's going to hook up right to there. Now that's got a cylindrical joint on it. I'm just going to play with that motion, turn that back to revolute so that it does have some horizontal fixing right in there. And then this right here is going to reach down and connect to right there. Now, just to help things out, I am going to move it fairly close so it's almost in position and ready to go. And then I'm going to come in here and I'm going to create a joint. I'm going to capture that position so that that's where we're working from. Want to get that hole right there. And then I want to get this hole right there because that's where the screw is going to go through. And again, this one's going to see it's giving us a warning and saying that it'll result in a conflict. That's because there's slightly different lengths right in there. So if we come in here and tell it that the motion can be cylindrical, there we go. That warning just disappeared because now this can be spaced off a little bit right here, and we'll either have to make that part a little bit longer or we'll just run a screw right through there and life should be good. Okay, so now looking at that, from the front side right there, we should be able to see that we come that far and the syringe stops. We come up that far and the syringe stops. So now we have a bucket, and the bucket can extend. If I look at the angles right here, that's at minus 34 degrees, and the bucket comes right back up there relative to that. And minus 17 degrees, we're getting quite a few degrees. Actually, I guess this is the one I really want to look at right here. From 20 degrees to the positive back to negative 132. So we're getting about 150 degrees of bucket transfer. Now, we might be able to do better than 150 degrees. We're limited by the stroke length right here, but now we can come in here and we can change our parameters. And let's just shrink this window down a little bit so that it doesn't block the entire view. And if we come in here and we start playing with some of our measurements, so we can take linkage arm length right here, and what happens if we make that go to 40? Okay, so you can click on OK, and now you can do your motion study. That comes all the way around right over. Oh, look at that. That actually, we don't bottom out on the plunger right there, but we are getting a really huge amount of movement. Now, one of the things you do have to watch out for when you see huge amounts of movement in the bucket and very small amounts of movement in the plunger is that there's always a trade-off of distance and force. So, excuse me. So if that plunger is moving a very small amount and you see the bucket moving a very large amount, then you probably don't have a lot of force being transferred to the bucket at that point. So the idea is to try and keep the movement on the plunger nice and smooth as the bucket moves back and forth. And now you can go through and you can optimize some of your dimensions in here so that you can have an arm that is dimensions that you happen to like with your own set of parameters for this.
Next lesson, we'll come back and we'll take a look and we'll say, well, okay, how do we start turning this into a fully three-dimensional arm for our syringe excavator? But if you've got this going back and forth like this, and you can see that motion and you can say, oh, okay, running into some possible interference problems down here. You might even want to start designing a bucket for your excavator now. We're going to take a look at more of that in upcoming lessons. Great job for today.